Good morning, everyone, and I welcome you to this session. Uh, and my talk today will be machine learning for urban computing. I will just share the slide deck and we'll proceed from there. For sake of bandwidth, I will stop sharing my video. So we'll begin with machine learning for urban computing, and you all can actually interrupt, ask questions in between, and so on and so forth. Okay. Okay. So let us start. Just a moment. Let me just set up my screen. So the agenda for today is I'll introduce you to the topic and then take you through some of my research work on urban computing for civic complaints. Then two other works which are based on social media data analytics for spatiotemporal diffusion analysis of tweets and Twitter-based extraction of traffic events. So the first part of the session is based on my research work that was published in ICIS. Uh, and it is analyzing civic complaints for proactive maintenance in city. So before we begin and go into the details of what the work is about, let me first introduce you to the concept of urban computing. So basically, urban computing derives upon the data that is collected by different sensors and data generators such as GPS equipped devices, satellites, and mobile devices, etc. The data could be spatial, it could be real time, it could be civic complaints. When I say civic complaints, I mean unstructured text that is entered into the system and so then there are different modules such as machine learning, data mining, visualization, etc. And they give inputs to the different services or applications. So we are primarily going to talk about civic complaints and its analysis. So the motivation of this work is as follows that usually these days people live in communities, and when they live in communities, basically because people don't have time, so therefore usually the communities offer a system, a digitized system to enter or log their civic complaints. The civic complaints can be complaints related to utility services such as power, or they could be services related to poor roads in and around the locality, noise, pollution, garbage, etc., etc. And these complaints are actually entered in form of unstructured text into the complaint logging system, and from there it is taken up for resolution. So the idea of the motivation for this work is to analyze the civic complaints and identify some critical complaints that are coming out from a particular locality or region, and see if there are different kinds of complaints which are correlated and co-occurring, and provide proactively solution to these so that the locality becomes a better place or better locality. Uh, Okay, and we will, while doing this analysis, we will also not just look at the location or the spatial aspects, we will also look at the temporal analysis of this data. So, For this particular work, we have looked at uh, 5 different aspects, such as garbage and unsanitary conditions, then parking areas and recreational park related problems, water and power cuts, then damaged roads, potholes, and noise and air pollution. So our objective would be to apply machine learning techniques to be able to identify and civic problems given a locality. So this particular work is really challenging for various reasons. And the first reason is that there are many different kinds of civic complaints. Those may be originating from a given locality or you know from a set of locations. There might not be just a single type of complaint. There might be different variety of complaints, and the complaints may be distributed so that somewhere they are very high in density, and from some other locations very less complaints may be coming in. So there the complaints may be varying in densities over a set of locations. Then there might be complaints having different criticalities. That is, there might be complaints that need to be solved in a very short period of time, whereas there might be other complaints that have to be that can be solved in a slightly more amount of time. And the lesser the time to resolve, higher is the criticality. Then there might be some correlations in the different complaint types, and so on and so forth. So now I'm going to talk about the methodology that was proposed in the research work that I'm discussing. So basically, in order to do this kind of analysis, which I've already introduced to you, we performed analysis in 2 phases. The phase one was involving a broad spatial analysis or spatial clustering of the different complaints that were originating from the given locality. And the second phase actually involved fine grain analysis of these broader spatial clusters. So accordingly, there are phase one and phase two. In the phase one, the broad spatial clusters are formed, and in phase two, within each of these broad cluster, the different kinds of complaints are actually taken up, and uh, they are looked into, and solution is found out for each of these types. So we'll go from here. Okay. So in the first phase, the complaints are entering the system in form of the text, and it will also take the location information and pre-process the data. After that, broad clusters will be formed in the phase one, and in the phase two, the categorization of the broad clusters in form of different kinds of complaints will be taken up, and profiling of these complaints will be done into different categories, and this information will be used for proactive maintenance of the given place. So let us take the first phase. Now, while performing the clustering, we are going to utilize certain characteristics of the data. The first is the spatiality or the location information that is available in the data. And then the density of the complaints, and finally the type of the complaints. So I'm going to discuss each of these one by one. So what we have tried to do is that using the density of complaints, we have tried to form hierarchical clusters using a dynamic size grid. Now, what do we mean by a dynamic grid size grid is as follows, that let us assume that we are having a set of locations, and the set of locations can be enclosed in this bounding box, which may be the latitude longitudes. Let us assume that we are enclosing the locations or the set of locations under study in a bounding box, and then we'll go on dividing the bounding box into four quartiles, and this will continue till the density of the points inside the cell is less than or equal to some threshold. Now, what is the idea of doing this? The idea is as follows, that we want to identify, groups of highly populated areas or portions inside this bounding box. So it can happen that a large number of complaints can actually come out of some sub portion out of the given larger portion, and uh, it may not be actually necessary that if a set of locations are enclosed in a bounding box, then all of the areas inside it is having a lot of complaints. So it might be possible that a small portion inside this big box is having complaints coming out of it. So the idea is to be able to identify that portion and remove those areas which do not contain complaints or are sparsely containing the complaints. So for this purpose, as I've already told, we'll use the concept of density, which is the frequency of complaints over a given area. Now, the next thing is that we'll try to profile, as I already told you. So in phase one, we find out the broad clusters. And in phase two, as I mentioned earlier, we are going to look at these broad clusters and profile the complaints based on their criticality, type, etc. For profiling, since there is no standard method and not much work has been done into finding out the criticality of the different civic complaints given a location or a set of locations. So we have proposed to use the following factors. The first one is the criticality based on the density of the complaints coming out of a given location. So we assume that the higher the density of complaints, the higher is the criticality. The second factor that we thought we should use for profiling the criticality is the time to resolve. So, if the time to resolve the given complaint is short, then definitely the complaint must be of higher criticality. Whereas, if the time to resolve is can be larger, then this means that the complaint is not that much critical. For example, if there is a break in a pipeline, a water pipeline, and large amount of water is getting lost and it is getting logged somewhere in some location, then definitely it's needs to be resolved very fast, and it may be a high criticality complaint because of the less time to resolve the complaint. Then the third factor that we considered was that some complaints actually, different types of complaints co-occurred. So if this is happening, then we wanted to give it a higher priority. And finally, we also wanted to give some priority to the time of occurrence of the complaints. So based on all these factors, what we did was that the clusters that were formed, we tried to look at the sub-clusters within the broader clusters, and the idea was to identify the specific complaint types within those clusters. So each cluster could actually have could be a mix of different complaint types coming together. So the idea was to segregate the subclusters within the broader clusters formed in phase one based on the complaint types. And for this purpose, we formulated some base vectors and location based vectors and used them to categorize the clusters. And then each cluster, after having formed the subcluster, we try to look at the criticality of it. So as I said that we use some location-based feature vector we populated, and then what we did was that we tried to form the base vectors corresponding to each and every type of complaint. So there were different base vectors, and there were 6 different base vectors corresponding to 6 different complaint types. And then what we tried to do is match the location based cluster with the base vector and saw where there was a match, and this helped us to identify the type of the complaint coming from a given locality. So after having identified the type of the complaint, the next thing was that we wanted to look at the criticality or the profile of the complaint. So for that purpose, as I said, that first thing that we considered was the density. So the density of the complaints. So now this was also very challenging. And what was the reason? The reason was as follows. Sorry. The reason was as follows, that there were locations which were bigger and were having high number of complaints coming out of them, but still there were some smaller portions that were still more packed with larger number of complaints. So the question is that a small area which has a very high number of complaints would be more critical as compared to a larger area with a slightly less density of complaints. So all these factors were considered, and a value of criticality ranging from 0 to 1 was assigned to this factor, which was computed. Then the second thing was the average time to resolve the complaint. Since in the data log that we had, we were already given the time that was taken to resolve. So we used this time to profile the complaints on the average resolution time. Lesser the resolution time, more critical would be the complaint type. And again, values were assigned from 0 to 1. Then we looked at the temporal or the time of occurrence of any particular given complaint, and we divided the time of the day into 4 quartiles or 4 portions, and tried to see which type of complaints was occurring in each of these particular 4 time slots. Then finally, using that, we had a typical time slot factor or the TTS factor assigned to each complaint type. And then using all these factors, we computed the criticality score. So we proposed to use the density, the time factor, the typical time slot, etc., and co-occurrence factor to compute this criticality score, which ranged from 0 to 1. Now, and using this criticality score, we try to profile the different complaints, and accordingly, the locality, the different complaints belonging to a locality could actually be identified and catered to. Now we'll come to the different experiments that we did. So the experiments were corresponding to, just a second. They corresponded to almost all major cities of the world. But for sake of space and time, I have only included some important cities of USA as well as Bangalore, which is one important city of India. So, for example, from the city of Austin, which is 11th most populous city in USA, we collected 100,000 complaint records. For Boston, 33,129. For Chicago, 64,267. New York, 100,000. San Francisco, 98,877. And for India, the data was only available for Bangalore, but it is a very important urban area, urban locality, and it's the 5th most populous urban city. We could collect 25,986 complaints for the city of Bangalore. The different attributes that were available in the data set included complaint number, date of complaint, complaint type, description, closing date, etc., etc. So the first thing what we tried to do was that we tried to look at the location-based cluster using the bounding box and the polygon plots, and we tried to see whether the location-based cluster that we found were actually matching with the given ground truth or not. So in the ground truth, as I told you, that the locations in form of latitude, longitude were given, and what we tried to do was that we tried to form the clusters and match them with the given locations to look at the correctness of the clusters that we formed. So we saw that our phase one broad clustering, which involved spatial clustering, actually formed the spatial clusters which matched with some of the standard existing techniques already. So the idea was to match the clusters in the phase one that we formed with some other standard existing algorithms such as grid clus, and we found out that broadly the clusters formed by our method and that by the existing methods matched. So this showed that our phase one actually was effectively forming the spatial clusters. Now, since the phase one clusters were ready, we are going to do further analysis. In order to do the further analysis, I will just, in addition to the results of the cities that I showed in the table earlier on a slide, I just want to focus on New York region and explain some of the interpretations. And for this purpose, I think many of you already would have visited the New York region and are knowing about the different important suburbs there. But I thought that I will also include this information. So, so the different suburbs in the New York City, there are five important suburbs. One, the Staten Island, Brooklyn, Queens, Bronx, and the most important is Manhattan, which is the posh area, and the Times Square is a part of Manhattan. And then it's a sea area, and therefore you have sea in and around the city. So, yeah, and one important thing that I want to show you, because I'm going to use this, is that the Manhattan has a very big park called the Central Park. It's a very famous park in the heart of Manhattan, and it has the Times Square. The Times Square is surrounded by a lot of landmarks such as the Ripley's Museum, the Empire State Building, Manhattan Mall, Guinness Book of World Records Museum, Wax Tussauds Wax Museum, etc., etc. Everything is not written here. I'm just speaking it up because they are there on the Times Square and everybody goes to have a look at them. And the Times Square is full of people, mostly starting from evening times up to early morning hours. So it's a very busy area full of noise, lot of advertisements, concerts, music, shows, everything goes on at Times Square. Now, why I'm saying this, all this is that I'm going to use it for the interpretation of the results that we found out. So many of you will already know this. Those of you don't know, may for them it will be important to know. In the Brooklyn area, there is an important park called Prospect Park, and I'm going to talk about this in some of the coming slides. So I've showed them to you. And around the park, there are roads which connects the park to the different other localities. So this is the Prospect Park. You can follow the cursor, and around it are roads all around it. Now, so I'll take some of the important locations one by one in for the city of New York. So if we look at, uh, you know, some of the important, let us look at the Prospect Park area in Brooklyn. I just showed you on the map the Prospect Park in the Brooklyn area, and we tried to analyze the complaints which are having high criticality for the Prospect Park area. And we found out that the park is actually visited almost throughout the day by a lot of tourists and local residents who bring their children, or they do a morning walk, or they do some kind of exercises, trek around the park, etc. So this park is seeing a lot of traffic, and people usually commute by car. So there are a lot of parking related. So when I say parking, it is the car parking. So there are a lot of car parking related complaints because there are no dedicated. The park is a very ancient park. It's not a new park, and therefore it is not surrounded by a tradition, a dedicated car parking. So people who come to the Prospect Park, they do car parking all around the Prospect Park area on the road, and they do parallel parking on the road. So, and there is a lot of problem because there is very less space. There are many, so the traffic of the cars is much more than the amount of space available on the roads that are around the Prospect Park area, resulting to a lot of car parking related problems. And then this leads to a lot of congestion, traffic related problems and congestion and jams in this particular area. And the road which is surrounding the Prospect Park is the Dahil Road, which I have shown here. And the Dahil Road is mostly congested. It sees a lot of traffic. So this is a general interpretation, but by doing the criticality score and complaint analysis, we found out that the park sees a lot of illegal car parking related problems, and it sees a lot of pollution, traffic, etc. So all of them are also correlated because there is very less space to do car parking. This leads to a lot of congestion, traffic jam, and this leads to a lot of air pollution, etc. So these were the important problems that were identified using our analysis. And then we tried to find out the correlated complaint types for the Dahil Road in the Brooklyn area. And we found out that the correlated complaints were like air pollution, car parking, street services, noise, etc. And they are all correlated to traffic and noise. So these were the correlated complaints. And now, if we look at so what we tried to do was plot the criticality scores. So what you are having is the criticality score on the vertical axis and the different kinds of complaints on the y-axis. So it is easily noticeable that the car parking related complaints saw the highest criticality score. And we also try to analyze, and we then it was air pollution which was the next highest, and so on and so forth. And we also tried to see the time of the day where this was occurring, and it was found out that the complaints were occurring almost throughout the day, right from 6 a.m. up to 12 a.m., that is night 12. So people were visiting this park throughout the day. Only from 12 a.m. to 6 a.m. There were very less complaints. So this is just, we try to look at the goodness of what we found out. So we found out that in the Prospect Park area, there was a lot of news that was coming up in the different news fora related to car parking problems of the Prospect Park area in Brooklyn County of New York. Then, if we look at the Manhattan, Manhattan is a very, very important suburb of New York City, and primarily it is suffering from noise complaints. So, if we look at the criticality score, we found out that the highest criticality score was coming for noise. As you can see on the in the figure on the right, and if you follow the cursor, you will see that noise had the highest score, followed by other street related problems. Now, and this criticality score was actually coming for the time slot of 6 p.m. to 12 a.m. So the noise was highest during 6 p.m. to 12 a.m. This is what our analysis showed. We also tried to plot the criticality score, and this is the 6 p.m. to 12 a.m. Time slot in which the score was the highest. And it is also very intuitive because the Manhattan area, that is the Times Square area in the Manhattan county, sees a lot of noise during the evening times when people walk on the street, they stand there, they watch shows, they visit the different landmarks at the Times Square. And therefore, up to late night, it sees a lot of noise. And this is just a ground truth to show that in the news also this has been reported, and there are images of people walking with their ears closed because of the high amount of noise in and traffic in the Times Square in Manhattan. So if we look at the New York region, what we saw in totality was the primary type of complaint coming for the New York in general was traffic, and it was coming between 6 a.m. to 12 p.m. or 6 p.m. to 12 a.m. And the noise was also coming in the same time zones. And probably there may be different reasons because people go to offices in the morning and evening. Also, there's a lot of nightlife in New York, etc. And the co-occurring complaints was noise and traffic. There was a lot of congestion and traffic-related problems in the New York City area, which is quite densely populated in most of the portions. And the traffic was also correlated with not only with just noise, but with air pollution and uh, other things. So, like that. Uh, so, just a second. Just a moment. I think there was a call. I will just answer. So, so these were the problems that were associated in general for the New York City, summarized over all the four suburbs. Then, if we look at Boston, what we found out was that Boston saw a lot of illegal car parking related problems, and they were occurring for almost all timestamps. And the illegal car parking was co-occurring specifically with weather issues such as snow, and it was also coming along with related to parks inside the city of Boston. Then there were inefficient street services, traffic problems, street light, etc. So all these problems were correlated and they got a very high criticality score. Now, if we look at the city of Chicago, then what is happening is that Chicago is a very different city. Uh, because it is seeing problems which are primarily related to street services such as street lights and uh, sorry, car parking related and public health and safety related problems. So these were the important issues that were there with the city of Chicago. If we talk about SFO showed primarily street-related problems, specifically in context to street light and noise for almost more than half of the day. And this correlated with traffic, etc. Now, let us talk in more details about the city, the only Indian city which we could study for say because of the fact that we got data for it, and it was the city of Bangalore. So the city of Bangalore actually, this is just a box plot to show that the clusters that we formed within the city of Bangalore matched with those formed by any standard other existing algorithms. So, and okay. Now, if we look at the different localities, though the analysis was actually done for each and every locality in Bangalore, but I will show some important or popular localities which face some common problems known to everyone who would have gone to Bangalore or is well versed with Bangalore. So, the first locality is that of the Banaswadi Road. This road sees a lot of garbage related problems, and also the streets, that is the road, is having lot of electricity problems. Most of the street lights are not working, etc., during the time of the study. So, accordingly, if we look at the figure in the right upper portion, we try to plot the I mean criticality score we computed in the proposed approach versus the complaint category, and we found out that garbage, as you can see if you follow the cursor, showed the highest criticality score, and this score was seen during the 6 a.m. to 12 p.m. slot. That is, maybe the people were cleaning their homes and just throwing the litter on the road instead of throwing them in proper places. Also, the garbage problem and the dirty road problem in the Vanaswadi area was coming due to defecament. That is, people passing stools on road, and it was seeing a criticality score of 1. So it was a very, very important problem because the roads were full of defecament. And possibly this is because this road is seeing lot of low income people or marginalized people living in this area. So this is just the ground truth in the lower figure, just to show the amount of litter on the road during 6 a.m. to 12 p.m. until it is cleared by the municipal corporation or the authorities of the city. Then, if we look at another location, which is the Marathali area, there was some time back the Marathali traffic jam, which came up a lot in news. You can see in the lower image, lot of cars and vehicles all interlocked and just stagnant on the road. And there were lanes that were intermixing at several points and people crossing the lanes and so and so forth. And it lasted for almost the whole day. And it took a lot of effort for the local authorities to clear that jam. So now, according to our proposed technique, we try to plot the criticality score versus the complaint category, as in the figure or on the right side on the top portion, and we could easily find out that the Marathali area was suffering from a couple of problems. And what were those? First of all, there was this traffic problem. Lot of traffic problem was there, and in addition to the traffic problem, so you can follow the cursor. I'm showing you the traffic problem that showed a very high criticality score. And along with that, it was seeing a lot of drainage and potholes related problem. The criticality score is high. It also showed stray animals on the road. It showed garbage on the road. Then it showed drain related problems on the road. It also showed street lights were not working for this area. Then it also showed that there was a lot of noise pollution because a lot of jams were happening, traffic jams, etc. So, and there was also defecament on the road in the Marathali area, and you can see that it is having a criticality score of 0.6. So this Marathali area was full of traffic problems, along with that garbage, broken road with potholes, improper street conditions, and lot of defecament. And this was resulting into traffic jams. And you can see that the score of the traffic complaints was 0.92, and primarily it was between 6 a.m. to 12 p.m. And also intuitively, this is the time when people clean their homes or go for for natural calls, etc., etc. And people also go to offices, schools, and all during this time. So this is the summary of the results for the city of Bangalore. So Bangalore saw a lot of traffic between 6 a.m. to 12 noon and 6 p.m. to 12 a.m. And intuitively, these are the two time slots during which people go to, children go to school, students go to colleges, people go to work, and so and so forth. And sometimes in the evenings, people go for shopping or to buy their daily requirements. So evening also additionally sees that. Then the same time hours also showed lot of noise. So in the city of Bangalore, traffic was co-occurring with noise-related problems, and there was garbage and sanitation and mosquito-related problems, and then traffic was correlated with potholes, improper street lights, and public amenities. So these were the different problems that the city of Bangalore saw. Now, looking at the overall summary of some of the important cities that I've included. So, it is very clear that Bangalore was very similar in terms of the complaint types with the city of San Francisco as well as with Boston. So, you can see here the city of Bangalore suffers from insufficient street services due to traffic and congestion, and the city of San Francisco also has the exactly same kind of problems, and so is Boston. Whereas the city of Bangalore, San Francisco, and Bangalore and New York are not at all similar to each other, because New York sees traffic noise and related complaints, whereas Bangalore sees insufficient street services leading to traffic and congestion. Also, if you look at Bangalore geographically, in the sense that it is a seeing similarity with San Francisco and Boston. So, with this, I'll conclude this portion, and I think I will stop sharing and open for questions before I continue with my next sub portion for today. So, I think I will take any questions if there are. You can type on the chat and I will address them before I proceed to the next portion.
Yeah, participants, please, if you have anything to clarify, you can just type on the chat box. Madam will respond to your queries.
Shirish, you want to know what are the key challenges in urban computing? So, urban computing has a lot of components, as I already showed. So, there may be, different types of modules related to urban computing, such as those related to weather, or those related to traffic, or those related to utility services, or those related to some buildings, planning, roads, and so and so forth. So all these are different challenges that are associated with urban computing. So design of good roads, making all the locations reachable by roads, then having problems, addressing problems related to weather, such as fog, snow, or other weather problems, heavy rain, etc., water logging, floods, and so on and so forth. So all these problems are actually urban related to urban computing, and all of them have different kinds of challenges associated with them, and accordingly, different methods have to evolve, and their related data has to be studied. The data in itself could be in form of images, it could be in form of text, it could be in form of numbers, and accordingly, the techniques have to be evolved for them. So if there are no other questions, that I can go to the next uh, problem. I will just stop sharing, stop the video and share the slides. So now I will come to the second portion uh, of today's discussion, which is on using machine learning techniques for social media data. In this, we are specifically going to discuss our study, which is based on Twitter data. It was published in IEEE Big Data Congress. And this involved a spatio-temporal diffusion analysis of tweets related to different events that were happening. So let us just start with this. So what is the motivation for this work? So the motivation for this work is as follows, that there are different kinds of events that are happening in the world around us. And it's very important to get a insight into what are the different characteristics of each of these events. What is the cause? What may be the concern? What is the target population? And what is the inherent nature of the events while they propagate on social media? So we are going to do this kind of analysis, and for doing so, we'll do a spatio-temporal diffusion analysis, which you will see as we go along. So here, there are different kinds of events. I've already told you what is the problem at hand, and the events that can be looked at could be long events, short events, or they could be planned and unplanned events. So planned events are those which are known in advance, whereas unplanned events are those which are not known in advance. They just come up, such as occurrence of a pandemic. Nobody knew that there would be pandemic, but it just came up. So it's an unplanned event. Then there are popular and unpopular events. Popular events could be, for example, Cricket World Cup, and there could be unpopular events. Then, so accordingly, I have listed some of the events that we have studied, though we have almost studied more than 50 type of different events during the study period. And but for sake of space and time, I've not included the results of all of them, but I've included the results of some of the significant events. So some of the significant events include the natural events such as the spread of Ebola, floods, etc. Then there are political visits of important personalities from one country to the other. Then there are international movies that are launched. And then there may be elections at the national or the regional level. Then launch of Bollywood or Hollywood movies. And then there can be events such as terrorist attacks. So this is the description about the data set that we collected. We had around 0.69 million tweets collected for Ebola disease, uh, which started from South Africa. And the duration of the tweets were between 5th of November to 22nd November. Similarly, there was data collected on the event of terror attacks in Paris. Then, so it resulted into 0.41 million tweets. Then Obama's visit to India also led to the collection of 0.24 million tweets. Delhi elections, 0.20 million tweets. And alongside, you see the hashtags, for example, hash Ebola, hash Obama in India, etc., etc. And then we also collected the data for India-Pakistan World Cup that happened in February of 2015. And the event took place at Adelaide, Australia. And we tried to collect the data uh, for that particular event. Then there was this launch of the Hollywood movie 50 Shades of Grey, and there were 0.29 million tweets that were collected. So this is a framework, proposed framework. We had the tweets getting collected and being fed into a module which performs data pre-processing and cleaning. This After that, further the after performing the pre-processing and making the tweets ready for further analysis, a three-dimensional analysis was done on them to identify the spatial clusters or spatial information, the temporal information, as well as the retweet network analysis. And all these three were given as input to the final hybridized module, which is called the spatiotemporal diffusion analysis module. So now let's come to the spatial, information. So as I said that first we collected the tweets. The tweets required to be pre-processed because many of them had noise, or it had missing values, or it had values that carried no meaning. And therefore, what we tried to do was that we tried to collect, pre-process the data, and the pre-processed data was then used to tag it. Okay. The latitude, longitude was contained in some of the data. So the some of the data that contain the latitude, longitude could be used directly. So the locations were extracted from the data, and the this was used for the purpose of our analysis, whereas other locations, the other tweets that did not contain the geolocations had to be tagged with those locations. So this is just the distribution of tweets that contain the geolocations implicitly in the data that was there. Then this is the distribution of the tweets that was actually geocoded by us. And it is very clearly visible that, so these are the two put together. It is very clear that the distribution, overall distribution of the locations that were available on the tweets versus those which we tried to find out actually matched. Only the number of the distribution was the same, only the number of locations increased. So this is just a summary of the tweets. So we found out that for the event hash Ebola, out of a total of 6,90,713 tweets, only 0.85 percentage of the tweets were actually containing the geocodes, and the rest of the data had to be actually geocoded. Not all of the data could be geocoded, so the total amount of data on which we could add the geolocations was 43.21%. Similarly, for Delhi elections, we had 7 lakh for 53, approximately 54,000 tweets. And out of this, the geolocations, geocoded locations were there on 54.91 percentage, like that, so and so forth. So what I want to show you is that most of the data, you can see the fraction of the tweets having the location is very small and always less than one. So it was like one or less than one percentage of the tweets only contained the locations. The rest of the 99 plus percent data did not contain locations. Now, this would go a waste if we just discard it like that. So, we try to intuitively add locations to it and then to utilize it. So these are the experimental results. In order to perform the analysis, what we tried to do was we assumed something called the origin location. And what is the origin location? The origin location is the one where actually the event occurred. So this is called the actual location or original location. And there are concerned location, that is the one where we are trying to see what was the effect. So concerned locations are any other location except the origin location. And what is the origin location? It is the one where the event occurred. So what we wanted to find out was that what is the worldwide distribution of the tweets, how does the cumulative frequency of tweets change with respect to the distance from the original location? And then, if the event, is associated with other events, or it is associated with other multiple locations, then which is the location that dominates the discussion? So these are some things that we thought we will explore. This is just a distribution on a pie chart for the hash Ebola tweets. And we can see that the major chunk of the tweets are actually coming from USA. The blue portion is USA. And the next higher slice is coming from Sweden, and so on and so forth. So basically, even though the Ebola originated from South Africa, but the maximum amount of tweets did not come from South Africa, which occupied a very small portion of the tweets. But the tweets primarily originated from USA. Even when hash Ebola or Ebola did not originate from USA, but people in USA were maximally discussing this. So USA and UK saw a lot of discussion on hash Ebola, followed by France, Brazil, Argentina, and then South Africa, and lastly by Canada, India, etc. Then this is another event, which is a very interesting event, in which President Obama visited India. Uh, and this was the study duration in which this had happened. So usually the visit of US President of India was actually foreseen like a global event, because it was US President, the most dominant country in the world, US, visiting India. But what we found out from the tweets, so it should have been a global event. It appeared to be a global event, but if we look at the tweets distribution, we found out that most of the tweets were getting generated in India only. So the event, which was looking like a global event, turned out to be more local. And across the world, only this green, you can see the pies slice in the green color, was the only other country that was talking about the visit, and this was basically UAE. And UAE was talking about Obama's visit only primarily for one purpose, which was that the visit of Obama in India was followed by the visit of Obama to UAE. And this was possibly the reason why somewhat some people were discussing, whereas the maximum discussion was only happening in India. And so Obama in India, which was supposed to be a global event, actually was localized broadly only to India. So these are the conclusions of the experiments, that India and USA showed discussion. UAE showed the next amount of discussion, followed by Pakistan, Bangladesh, Russia, Indonesia, and others. So we also tried to do a plot of the distance versus the cumulative frequency of tweets with respect to origin. So origin could be anything. Origin could be any country that is under discussion, or it could be the original location where the event is occurring. So, for example, if we talk about the India-Pakistan World Cup, it actually happened in Adelaide, Australia in 2015. So we have tried to draw the distribution of the cumulative tweet frequency with three different locations as the origin. The first one is the origin from Adelaide, Australia itself, and it is shown in the blue curve. So what we can see is that in Adelaide there is hardly any discussion about the India-Pakistan World Cup, and it kind of remained always almost to zero till the distance from Adelaide became equal to 8,000 kilometers up to 12,000. So between 8,000 to 12,000 kilometers, if we look on the globe, the major countries which will be there from Adelaide, Australia, or India and Pakistan. So you can see that the tweets did not increase, or there the countries between Adelaide, Australia, and India and Pakistan, did not discuss much at all about the Cricket World Cup match in Australia. So this World Cup, as the name also suggests, it's a Cup, and supposedly it should have been a global event, but it turned out to be more local to India and Pakistan. And you can see that at a distance of 8,000 from Adelaide, Australia, suddenly the cumulative frequency increased. And the reason is that between 8,000 to 12,000 kilometers, there is India and Pakistan. And after that, also the frequency stagnated. So, not many countries are discussing much. So, before and after, nobody is discussing, only India and Pakistan are discussing. Then the second plot is that of the distribution, cumulative distribution with Pakistan as the origin. And what we could make out clearly is that the India-Pakistan Cup was very much discussed in Pakistan, and the plot in the green showed the discussion frequency in Pakistan for the World Cup, World Cricket Cup. And similarly in India also, there is a high percentage of tweets contributing to the discussion about the Pakistan-India World Cup. Now, if we look at the visit of Obama in India, then also what is happening is that the Obama's visit to India was seen, and the tweets were plotted. In the first one, USA was taken as the origin. In the second one, India was taken as the origin. So it was seen very clearly that cumulative frequency, if we look at India as the origin, increased immediately soon after, with the origin in India, and after a while it got stagnated. That is, the visit of Obama to India was not being discussed much in any other country except India itself, and somewhat in Pakistan. So this is USA. If we look at USA, USA also does not see much contribution in terms of tweets coming out or getting generated in USA. It was only when the president reached India that there was a discussion on his visit. So this is about Obama's visit. Then this is about Delhi's election that happened in the year 2015. Again, we found out when we plotted the curve that as we increase the distance of the event, if we talk about Delhi election, then the origin would be Delhi. So we saw that as the distance increased from Delhi, we saw that the distribution or the distribution showed a lot of tweets from across the globe, because the number of tweets is increasing beyond a distance of 2,000 kilometers. So, in other words, Delhi's election actually was supposedly a local event, but it turned out to be a global event if you look at the tweet distribution. Then This is the distribution generally for globally occurring events. So, events such as the hash Ebola disease, the Paris attacks of terrorists, and the 50 Shades of Grey were actually taken to be global events. And if we plot their frequency with respect to the origin, then what we find out is that the tweets initially are very less, and the global events see that the tweet distribution is gradually increasing with time. That is, it doesn't happen that there is a steep increase and after that a plateau. It doesn't happen like that for the truly global events. So the truly global events are those which are not just global actually, but they may be local events getting discussed globally. And we found out that such events are discussed in all countries, and therefore the cumulative frequency of tweets goes on increasing gradually with respect to distance. Then this is just a diagrammatic picture showing the temporal analysis. The temporal analysis of the Delhi election tweets were done, and these bars are showing some specific days on which some comments were made by political persons, and this increased to a large volume of tweets on that particular day. For example, the first day in red was the day when Kiran Bedi made some statements against Kejriwal. So basically, this is the distribution of the tweets during the India-Pakistan cricket match, and we can see clearly that just before the World Cup match day and after it also, there is hardly any discussion. So most of the discussion in this kind of event, see, it's a very interesting event because the discussion is completely different. Before the day of the match and after that, there is very minimal discussion on Twitter. But on the day of the match, these are the tweets. They are coming primarily on the day of the match. That is during the starting and after half of the match is over. You can look at the timestamps, and in between, the number of tweets just became almost zero. So when the team swapped the fielding and all those things, batting, again the discussion was a lot, and then like that. So this was supposed to be a global event, the World Cup, but it has turned out to be more localized, that too only for one day of the match. Uh, This was about the Obama's visit in India. We can see that these are the days of the visit. Primarily, 26th January was the day of the visit in India, and we can see that before, in the days preceding the visit and after the visit, so there was very less discussion. You can see the very small black bars, and a large amount of discussion happened during the visit itself, and that too it was localized more to India only. It wasn't happening in USA also, even though the president of USA was coming to India. It was primarily happening in India and somewhat in UAE. And these bars show that it was confined to the day of the visit. Then, if we talk about the launch of the movie, we can see that the launch of the movie saw a lot of discussion. So you can see the different dates. It was 6th of February, then it was 7th, 9th, 10th, like that. So the launch of the movie, and the launch happened during the interval, which is shown in between the red bars. So now again, this is a completely different kind of a event. Here the discussion wasn't happening much before the launch of the movie. You can see the minimal tweets, and these are the global tweets. And then on the day of the launch, that is on the 13th of February, the movie was launched, and some of the tweets increased, not much still. Then on the second day of the launch, there was a high spike in the number of tweets, and then after that, there was a lot of post discussion on the plot of the movie and the acting, the cast, and all those things. So this discussion, this launch of the movie kind of, saw majorly the discussion post the movie. So, see, we have different events. Here it was a global, supposedly global event, but seeing discussion only on the day of the event. This was a global event like the match, and it was seeing discussion only on the day of the event and somewhat on the next day, but not afterwards or before. Delhi elections saw a lot of discussion before the election, after the election, on the day of the election, like that. So, so then what we concluded was that there were some global events which are actually turning out to be more local. Some of the local events, like the Delhi elections, were discussed across the globe and they were turning out to be global events. And this is a retweet network analysis. We saw that, for example, Hash Ebola was a more of a global event with which saw a lot of discussion all across the globe on all days. So there is a nucleus followed by uniform distribution around it. And though I did not mention, just like Obama in India, there was Modi's visit to Australia, and this was also studied, and we found out that this also turned out to be a global event. The distribution is similar. There's a nucleus followed by the sparse region. So the visit of Indian PM to Australia was seen like a global event. But if we did the retweet analysis for President Obama to India, it did not look like a global event. It looked like a global local event. So these were some of the interesting things we found out. This is just a summary of the retweet networks. And with this, I will conclude this portion and I will take a very quickly one more topic. And at this point in time, I will just stop sharing. And if there are any questions, you can ask me. So I think if there are no questions, I'll just quickly proceed to a smaller last subsection. So this work is about social interactions as expressed on Twitter for solving transportation related problems using machine learning techniques. And this work was published in AI 2020, which was held in Greece in June of 2020. So basically, the problem at hand is that there is a lot of urbanization happening in countries which are developing countries such as India, and its neighbors. And also, there are other developed countries, and most of them are suffering from a lot of transport related problems that there are transport services which get disrupted due to various reasons, due to floods, waterlogging, traffic jams, etc., etc. And people, many times they give the complaints related to street or roads in form of formal complaints, but most of the people in India do not indulge or into making complaints about traffic and bad road conditions. But they do express themselves on social media data and express their feelings. And so their sentiments can be found out by analysis of social media data such as tweets. And using that data, we can also find out problems related to street. So this is just a diagrammatic picture that people express their feelings on social media data. They may or may not complain about some problems, but they just express themselves and their problems on social media data. And in this particular work, I'm going to primarily focus on traffic incidents and patterns extracted from traffic incidents. And these incidents are the traffic events that have been found out by analysis of tweets, and their sentiments. So I will just give the literature review and I'll come to the methodology that was used for this analysis. So we collected the data and we processed it. The data collection involved collection of the tweets Then we extracted the features and used the features extracted for building machine learning models, and then did our experiments and found out the results. So this is the proposed framework. We have the tweets collected by the streaming API, and these tweets are pre-processed to clean them, perform some stop word removal, stemming, etc. And some of the tweets were labeled so that we could build a classifier model on them. After pre-processing the tweets were actually distributed into two data sets, the training data and the test data, and feature vectors were extracted. These feature vectors were fed into the machine learning algorithm and classified to identify the traffic event as the tweet as that related to traffic event or to a non-traffic event. So this is just an explanation on the data collection. I already told you how we collected the tweets. Different hashtags were used. The pre-processing was done just like any other standard NLP problem. The same methodology was used. So the punctuation marks were removed, blanks. Then there were some names, so names were removed. Then the hash symbols and the @ symbol that was there in the tweets were removed, etc., etc. And then stop words were removed from the tweets. Stemming was done to obtain the roots of the words, like that. So having processed the tweets, we then tokenized them into the part of speech. So we did part of speech tagging and converted the uppercase into smaller case, etc., etc. So, for example, if there was a tweet as you see in the table, then after removing the punctuation marks, tokenizing, stop word removal, stemming, lowercase conversion, finally we obtained the tweets in the final form that were usable for our analysis. In the next portion, we extracted feature vectors from the tweets, and for this purpose, different word embeddings were used. So we used the bag of words approach, the TF-IDF, and the word2vec. So these were the three different word embeddings that were used to extract the feature vectors from the given tweets. So the bag of words approach considered all the words that are or the terms that are coming in the tweets, and what we do is just make the feature vectors by populating the frequency of the words across the corpus of tweets. In the TF-IDF, what we try to do is that we count the occurrence of the words and then normalize it against the complete corpus of the documents. So this is TF-IDF, and then we have word2vec. So bag of words and TF-IDF both do not consider any semantics. So there is a word2vec embedding that considers the semantics of the words as well, and this was also used to extract the feature vectors. So we extracted the feature vectors from the tweets in three ways using bag of words, TF-IDF, and word2vec word embeddings. And then after obtaining the feature vector, we try to perform machine learning based classification to identify the traffic events versus the non-traffic events from the given tweets. So for purpose of classification, three different classifiers were used. The first one is the k-nearest neighbor, the naive-based classifier, and the support vector machine-based classification. So the results were analyzed against accuracy, precision, and recall, and the F measure. So what is accuracy? Accuracy, that is the amount of true negatives and true positives versus the total number of instances. So what are true positives? Those are traffic events which are classified as traffic events by our classifier. True negative means non-traffic events and classified as non-traffic events. Then precision and recall show the true positive versus the total retrieved and recall is the true positive versus the total that were retrieved. Then for k nearest neighbor, we wanted the appropriate value of k. The appropriate value of k was found out by plotting or finding out, that is by varying the values of k and plotting the misclassification error versus the changes in k. So, for example, we did find out the misclassification error with k equal to 1, k equal to 2, k equal to 10, k equal to 15, 20, like that. And we go on doing that. So we found out, and we went on doing this till only the error was increasing. We found out that the global minimum was at k equal to 9 for the misclassification error, and we chose this as the value of k for our further analysis. So here is the result for in terms of accuracy. So the accuracy was found out using the different. So we had three classifiers with us, remember, the k nearest neighbor, naive, and support vector machine. And all three utilized three different ways of feature extraction for word embeddings. The first method for feature extraction was back of words, the second was TF-IDF, and third was word to vec. And each of these accuracies are shown. So generally, if we look at any of these three, so if we look at back of words versus TF-IDF, no matter what the classifier is, and word to vec, we see generally that word to vec gives on an average the highest accuracy of classification. So we can say that word to vec is the best technique to for finding out feature vectors or extracting feature vectors. And out of the classification techniques, we can see that the if we look at the classification, then generally, if you look at the bag of words technique, then the support vector machine-based classification is the best. If we look at the TF-IDF based word embedding, then also support vector machine based classification is the best. If we look at the word to vec based feature extraction, then also the support vector machine based classification is the best. So what we can conclude is that out of the three different classifiers that we used them because they are very popular classification techniques, the k nearest neighbor, the naive based classifier, and the support vector based machine based classification. We concluded that the SVM based classification was giving the best results for classifying the events as traffic versus non-traffic. And out of the word embeddings, back of words, TF-IDF, and word to vec, it is the word to vec that gave the best results. So this means that if we concluded by our experiments that if we want to perform an event classification of traffic versus non-traffic events, then the word to vec is the best technique for feature extraction, and SVM is the best classification technique for this particular work. So with this, I conclude that there is a lot of scope of harnessing social media data for purpose of event classification, event analysis, and all. And definitely that's an open area of study. So what I'll do is stop sharing the slides, and I'm open to questions if there are any. Okay, Shirish wants to ask that as getting data from Twitter using hashtag, can we get data from other social media? Most of the social media, portals have restricted the collection of data. For example, earlier Facebook used to give the data. YouTube also used to give the data. But now YouTube has restricted collection of the data, and Facebook, using Facebook also you can get some amount of data. So you can use some other social media, and try to collect the data. You can definitely give it a try. Some others are giving the data.